Hello, and welcome to Topic 2 over matter, atoms, and electrons. This topic will cover what matter is, how it's organized, what are atoms, and how electrons are organized in atoms. Today's video is video 1, a basic introduction to what is matter, how is it defined, and what makes it up. Let's get started. Anytime you study chemistry, you're going to be studying the concept of matter. Maybe not matter explicitly, but sometimes its properties, how it interacts, the amounts of matter that are present. Matter plays a big part in what chemistry is and how to study it. First things first, you need to know the definition of matter, which I think I've mentioned in my previous videos. But matter is a substance that has a mass, which is a measurable quantity, and a volume, which also is a measurable quantity. Matter is composed of elements or combination of elements, known as compounds. And matter has both extensive and intensive properties. These properties basically give you what matter is and the different types of matter, because the properties of the matter tell you what matter is present. First property of matter we're going to talk about are extensive properties. Extensive properties are any property of matter that changes or relies on the amount of matter present. Your biggest examples are mass. The more matter present, the more mass will be present. Volume. Typically, the more matter you have, the more space it takes up. And count. The more matter you have, the more atoms you have. So if you have 5 grams of hydrogen versus 10 grams of hydrogen, there will be more atoms in the 10 grams of hydrogen. The second classification of matter's properties are intensive properties. Intensive properties are unique to the type of matter, and these don't change if the amount of matter increases or decreases. Intensive properties include color, its density, its flash point, its melting or freezing point, whether it's electrically conductive, whether it's chemically reactive. These things don't change based on whether you having 1 atom of a type of matter or 100 atoms of a type of matter. The properties are still the same, and these properties are intensive, much like the looks like bowling balls over here in the right. Each one has a unique color, and that color would be the same whether it was half its size or twice its size. If you take a look at the pictures here on the screen, you see 3 distinct groups of matter. Here on the left you see quartz. Quartz is a mineral compound found in rock soils and basically developed in earth processes. Quartz very clearly has a definite color, this clearish color. The black and brown is just impurities in the quartz trapped within the crystals. Each type of quartz has a specific cleavage fracture. They cut at specific angles. These angles don't change. These are the angles you can cut the stone or the mineral at. And those won't change based on the amount of matter. You can tell this crystal is slightly smaller than this crystal, but you can see the angles of the cuts are just about the same. Over here on the right, you've got water with some salt being poured into it. You can see the visibility of the salt is dependent on how much is there, but whether it dissolves in the water or not is irrelevant. So its visibility is extensive, but its solubility is intensive. And then up here you've got a mixture of, looks like some type of Mexican bean salad. So each component of the salad has its own unique properties, and if you would, think to yourself, what intensive properties do I see and what extensive properties do I see? Once again, we have some pictures of some matter. On the left we have wood burning. Now, if you know anything about fire and thermodynamics, you know that wood burns this nice pretty orange. That doesn't change whether it's a small chunk of wood or an entire tree. It's going to burn this nice pretty orange, and that has to do with the energy level in the material. That is an intensive property. Same thing with this propane. Propane burns a nice pretty blue. That doesn't change based on how much propane is present. If I turn this flame up, it's still going to be blue. And then this water droplet is going to cohese because that's an intensive property. On the left, these two flames, the brightness of the flame might change if more matter is burning, but the color will stay the same. So the brightness is an extensive property, whereas the color is an intensive property. Now, based on its intensive and extensive properties, matter can be sorted into quite a few categories. We're going to start with one of the most simplistic ways to sort and classify matter, in that, is it a pure substance or is it a mixture? Substances are pure, and we say pure because they have a uniform composition. They're the same all the way through. They're homogeneous. Whereas mixtures can be both uniform and heterogeneous, or different all the way through. It just depends on how the atoms and how the material in the atom is organized. Pure substances have a uniform consistency. They're uniform or consistent, and they're the same all the way through. Elements are pure substances. Gold, copper, silver, zinc, in their elemental form, are pure substances. Both compounds and elements can be pure substances. So water is a pure substance, as is gold, silver, and copper. As I've mentioned a couple times already, elements are pure substances. Elements are the simplest form of matter that is a pure substance. It's also the simplest form of matter that has a unique chemical and physical property set. There are currently, I believe, 118 elements defined by the ACS and the International Union of Chemists. Elements are composed of a uniform single type of atom. Every atom in a element is going to be exactly the same in terms of the number of protons that are present. Examples of elements, you're probably well familiar with their names: gold, nickel, zinc, copper, oxygen, carbon, things that we deal with in our very daily lives. Compounds are another classification of pure substance. Compounds are, much as the name suggests, combinations of different elements. They might be combinations of two of the same atoms, or they might be combinations of two or more different atoms. But compounds are just atoms that are bonded together in a definite ratio. The law of multiple proportions actually tells us that the same elements can combine in different ratios and give you different compounds. And the law of definite proportions tells you that every compound has a definite ratio. If you change that ratio, you change the compound. Compounds may contain or exhibit different chemical properties than the elements found in them. For example, water is H2O. It's two hydrogen atoms and an oxygen atom. Hydrogen and oxygen are both combustible gases. They will catch on fire if exposed to a flame, whereas water puts out flames. And it's also a liquid. So very different properties compared to what makes it up. Some other examples of compounds that you might know are water, carbon dioxide, carbon monoxide, glucose, starch. Basically everything we come in contact with is a compound. Very rarely do we come in contact with pure elemental substances. In addition to pure substances, you also have mixtures, and mixtures are combinations of elements that aren't bonded. There are two types of mixtures: homogeneous or homogeneous. Both pronunciations are acceptable, as well as heterogeneous or heterogeneous mixtures. Homogeneous mixtures are uniform. However, the blend of substances is not chemically bonded. Homogeneous mixtures are different than compounds because you can still come back and separate the components through a physical process, not a chemical process. For example, filtration or evaporation, distillation of water will separate salts and other dissolved substances in the homogeneous mixture. Heterogeneous mixtures are not uniform. There are at least two phases or unique components of matter that can be seen and discretely separated. So salt and sand mixtures would be a heterogeneous mixture. You could, if you really wanted to, go in with tweezers and separate each grain of sand from the salt. It would take a lot of time, but it's possible. And that's what makes it a heterogeneous mixture rather than a homogeneous mixture. Underneath the heading of homogeneous mixtures, there are solutions. Solutions are the most common form of a homogeneous mixture. They are composed of a solvent and a solute. A solvent is the substance that retains most of its physical properties when the two blend. Water is the universal solvent because it dissolves a lot of things. The solvent is the dissolving agent. It's the one usually in larger quantities in a solution. The solute is the substance that dissolves. So salt and water, much like you see right here, that's a solute. The salt is, and the solvent is water. Solutions, just like all mixtures, can be separated by physical means, typically through a process known as distillation or centrifugation. So, what's the matter? Gases, solids, liquids, and sometimes plasma.